This is, so that's our 600 transmitter mounted. And if you look at it, we can look inside here.
You should brought some honey so we can put that honey in there and see what the...
There's the motherboard with the EEPROM on it for a Viscometer. The power supply is in between. Got a display board back there. Yeah, just kind of your backplane board here for the analog outputs. Very basic. But that's what it would look like. So it's just a general purpose area in a box, as opposed to having it in that DIN mounted panel mount box that it usually comes in. So it's got the two outputs, so one will be the centipoise and one will be at temperature. So the way it works is, in the center, all the way down, this is a hollow tube. In the bottom of it, there's an RTD, which is measuring temperature. Because it's always important for the customer and for us when we calibrate it to know what the temperature is, because all those standard oils that we use to calibrate these, the charts on them, you know, go from something crazy like 40 degrees F all the way up to like 200 degrees, but we always calibrate at room temperature. So we have to know what the temperature is. We have to let that stabilize to be the same temperature as the jar. Then we look on our curve that it's X, and then we plug that in when we calibrate it. And then when we do our readbacks, it's at temperature to make sure that it's there. So really the way it works is, inside here there's what I call it's almost like a drive shaft down the center of this that's welded to the bottom here, which is hollow, which has got the RTD. And then it's got the outer sheath here, so it's really two tubes in one. And that center one comes all the way up to about this point here. And inside this dome, you've got two magnet coils on one piece of an iron square piece that's in here with some targets on it that are like magnets, and it resonates. So we drive an AC signal on the magnets, right? So it's alternating, and what happens is it makes the shaft like this, which is connected directly down the center to this. So this is resonating right now, and you can actually come up here and you can feel it. So as you see, what happens is we're basically at 0 centipoise, right? A little under. And when the thickness of the viscosity gets on it, so if I start holding it, now I'll feel it ramp up. There it is. I should have a pretty big reading there.
Ramped up to 473, 618, 665.
Save. Now if you come over here, you can feel it. That's how it works in those nasty environments. And just me holding onto it should also change the temperature.
How about we get a cup of water? Yeah, it does. Just change the water and the temperature went up a couple of temps.
There it goes.
Yeah.
You know, it's a big mass of metal, right? I would say you can get at least 2 to 2.5 times that length, but we don't make the whole thing this skinny all the way down. We have what's called a non-active extension, and that will be a diameter similar to the midway point on that raised face flange. So about 2-inch diameter all the way down, or 3 inches diameter, down to about here. Then it's machined in, and then this starts all the way down.
Yeah.
You're nulling the amp with the resonation.
So it's saying turn on, turn on, turn on.
It's just a PID loop, yep.
Yeah.
Because, okay, so we've got a coil on this side driving it, right?
Right.
But there's a feedback coil over here that's generating a voltage, a DC voltage. And when that DC voltage on that op amp says lack of signal, what happens? It tells the servo card, come back up to get me to X. Very simple. Nothing you can really do in the field with it except 0. Excuse me. And I guess if the customer bought the oils, they could test it, test calibration. There's really no need to. These things, as long as you don't bend it,
just leave
they
it alone,
work
right?
for years and years and
leave
years.
Leave it alone, yeah.
Yep. This is something that gets set in that pipe and they forget about it.
Yep.
But this is another device. If we're going to get into the process of selling them, with the quote was going to come a dimensional drawing of it, the suggested mounting for the application, and then when the purchase order comes in, an official drawing comes in, goes back to you or to the customer, and has them sign off on it. That's really what they want, because once we make it, it's
made.
Yes.
What is the suggested mounting?
Well, if it's on a reactor, it has to be mounted in a place where it's not going to get bent or hit by anything.
Okay. So
now, if it's a pipe mounted, we always mount them. Let me use the board here.
Sure.
Mount them in a T. So the sample comes up this way, because if you have thickness and velocity is it comes this way and goes this way, you're not gonna bend it. You can see what happens if we mounted it this way, it has straight shot.
Knock it sideways
On
there.
one side of the probe, it's gonna be less of a pressure, it's like an airplane wing, it's gonna wanna deflect, over time, depending on the viscosity and speed, you could bend it.
Alright, and how about,
So this is the preferred on a,
how about position in the pipe?
doesn't matter, you just wanna get this down.
Just get that
so
down
it
in
flows
there,
like
okay,
that.
in
And
the flow.
typically you want this would actually be a little bit longer, so really this pipe would be somewhere about here.
Okay.
But similar to that.
So just get it in the flow. So it stays in a flooded pipe. That's why you need it.
Yes, but you always want to put this in here because if this is an asphalt teams and stuff, you can imagine what happens is this is always going to cool first. You're always going to have this deadhead in here. And then when they shut the process down, this never gets cleaned out.
Yeah.
So what happens now, that's all solid there.
Yeah.
If this was here, and when they pull it out, they bend it. So we put a non-active extension, which would be, this one does not have a non-active extension.
Right.
Make sense?
Yes.
So again, it measures the viscosity and the temperature at the same time.
Okay.
So, what are our advantages on something like this? So obviously you guys have heard of Brookfield, the viscometers. Those are the ones that have the rotating plates. Well, it's a moving part, so when they put in the process, sand and grits and stuff get in there and wear that out. It's very fragile. Ours, it's hermetically sealed. There's nothing.
Can't get in there.
Just don't bend it, and it's gonna work. We make this one class 1 div 2 is we use intrinsically safe barriers, which get mounted inside the box, and then this gets a special blue cable, and it's intrinsic safety.
Okay,
We
so
do it
they'll
by
put it on
box.
their end, you can mount that in the box.
Yes, sir.
I
But this has to be mounted in a safe zone.
Yeah, but they can put your barrier in there, okay.
Yes.
Yeah.
Yes. These ports right here, these 8th NPTs, that's just purge, air purge, not water probing. The 800, the bigger one, which would have a way here where it's isolated from the electronics, internally welded, a pocket would have, that's when water cooling can go through it. But you can't put water on here, you'll get the coils. There's a limit, I think 120 C we say, for the coils without damaging them, because there is some polymer in the insulation on the inside of those coils. So we say, if you're gonna get up around that temperature, just run an air purge on it, it'll help it out.
Now, they got another barrier in there, that air was like a jacket around them coals, or it's?
No, it's just this whole open cavity inside it.
Okay.
It just kind of flushes the heat away.
No.
Very accurate. Like this is like the micrometer of our company. They really, really work. We can, when these are really correctly set up on a finished unit for low range, it'll see the difference in viscosity between city water and deionized water.
Yeah.
Yeah, you want to be careful of some certain vibrations, and they're in the manual what that is.
Yeah, 'cause
But it can interfere. Yeah.
Okay.
So you want to, if it's going to be mounted in a location with a pump that's pretty noisy and vibration, what we do is where that T is going to be mounted, we isolate that with the stainless steel flex pipe.
Oh yeah, expansion joint.
Yes, and then it's fine. Just a little bit to null it. That's all.
Yeah.
You want this dead right to the reactor where it's going to be, because that's your reference point, right? The pipe. So that's why we use these big 300 pounders with all the bolts, and you torque that down good. I mean, even you'll see a difference. Zero will drift on this as soon as you mount it, because you're not going to guarantee you're going to tighten them all the same. You
want
flex a
really
little
tight
bit.
and stay.
Not going to hurt it, but you just once it's in on air, then you just tweak it and adjust zero. And that's where it starts from. It doesn't affect the calibration. Okay. But yeah, because you're putting a lot of torque. These are big bolts that hold that sucker.
Oh yeah. So that